Okay, cool. I guess everyone can hear me in the back. Cool. So, buenas Alicante. It's great to be here. It is just amazing to be here again, and today we have a lot of things to discuss, like hydration, islands, resumability. Oh my, we should probably start. And by the way, if you feel like something is really confusing or deserves further conversation, look for this emoji at the bottom of the slides. It means let's discuss this afterwards. So this is basically what we want to cover. We'll discuss the past and the future of something. We'll talk about islands, of course, resumability as an alternative to hydration. We'll discuss streaming when it comes to server-side rendering and specifically selective hydration. We are in a React conference, so we got to talk about RSC, and then we'll draft some closing thoughts on top of everything we discussed. But I guess that all of these rendering patterns and etc., it starts with this question, like how and where we want to render something. So these days we can render things on a web server, we can render things in build time at a build server, in the browser, or as we saw with Facundo, at the edge. And we can also do that with different ways. We can render everything at once, or we can take approaches like partially or progressively rendering stuff. And then we also have a bunch of other questions, like where do we handle navigation? Is that on the server or on the client? And what we exactly execute when something loads? Or even where do we handle the whole data fetching? Not to mention, like, what do you include in your bundle, or what do you serialize and send over the wire? So it's just a bunch of questions. And I don't know you, but I kind of feel like, okay, how did we get here in the first place? So to discuss this, I'd like to do a little bit of trip back in time thing, and that's when we get to talk about the past. Specifically, about 1995, that was like a really important year that basically we had like significant milestones in the history. I'm of course talking about PHP version 1.0. That was supposed... No, but seriously though, like those languages, those CGI scripting languages like Perl and PHP, they were just amazing because they basically allowed us developers to render back-end data sources into the HTML. So for the first time, we could have dynamic stuff like real-time information or things coming from the database shipped to an end user's HTML. And the reason why everything was happening on the server is because back at the time, the servers were the powerful part of the network. So all the browser had to do was to interpret whatever was in the document and show that page. So yeah, it was about showing information, not interacting with it. And then JavaScript as a language and browsers as a platform, both of them got more powerful. And we could suddenly do a lot of cool things in the browser. That was the rise of SPAs and also the whole client-side rendering thing. And with client-side rendering, it was great because we didn't have to go back to the server for navigation, for example, and we could cache things like our core JavaScript model or the HTML and etc. on the CDN, which was, wow, great performance. And as the web got more and more interactive, we saw this rise of SPAs and client-side rendering. But then we had this first gotcha moment that we now had to kind of think about, okay, we should probably optimize this one bundle for a user because they might be downloading that in a busy city center with a bad connection and etc. And we're like, Eureka, again, let's go back to the server. But this time, we were doing something, we're doing what we call SSR, which is not server-side rendering as we had with Ruby or PHP. I really like this quote by Ricky from the React team because basically what you're doing is you're server-side rendering, client rendering. But SSR was great, so once you had the HTML, it was ready to be displayed really fast and everything was like, okay, super fast performance. And a lot of things, because you were rendering there on the server, you didn't need some specific browser features, so you ended up getting some higher compatibility. But it was then that we had, okay, interaction again, and we started talking about hydration. So I'm going to do a little bit of an intermission right now to talk about hydration. So one of my favorite definitions of hydration is this one by Mishko, that is the process of attaching behavior to declarative content so that it becomes interactive. And hydration first comes with a couple of challenges. Of course, you have to associate the down elements with their corresponding event handlers. You also, on every update that the user triggers, you need to update the state of your app. And of course, once the state of the app is updated, you have to go through your component hierarchy to reflect that update. Hydration also comes with a couple of questions. For example, do we send the whole JavaScript every request, or we do some optimization, let's say, based on route? Also, how do you handle hydration? Do you do that top-down of your component tree? And if you do that, how expensive is that? And also for your developers, people using your framework, how do you organize that? How do you build the developer experience around that? And again, hydration also comes with a couple of issues, and one of them is what's called the uncanny valley. You've probably seen that before. So basically, in blue, you can see that you had your initial request, the HTML is there, and the view is painted, so users can see your app. But the JavaScript bundle is still not there. And even when it gets to the browser, it still needs to be parsed, executed, and etc. So the uncanny valley is this moment where people can see things, but they cannot interact with it. And if you expand on these issues, and you think about each phase, let's say you're getting the HTML. That's usually, and most of the time, fast. But then, when you have to download your JavaScript, this can be slow depending on the network conditions of your users. And then you have to parse and execute JavaScript. But again, this can be slow depending on the capability of your device, if that's, for example, a low-end mobile phone, or even on the amount of JavaScript you have. And last but not least, you need to recover state and bind all the event listeners. But again, this can be slow depending on the amount of downloads you have to go through and the amount of references you need to rebind to these listeners. Of course, there's a lot of resources out there exploring the challenges and the issues with the hydration. But over time, people were always thinking of ways to overcome that. And one of them was islands. And we started to listen a lot about islands back in 2020. But you know what's insane? There's this post called Declarative JS Components with VLoader.js. And this was published back in 2013. And if you check the top of the post, the guy's talking about attaching JS behavior to a chunk of HTML. So the idea has been there for a lot of time. Of course, not as we know it today. And then in 2020, we got this great post by Jason Miller, the guy from Preact, where he basically describes this model and calls them islands. And that's basically what islands are. This component-based architecture model that suggests a compartmentalized view of the page with static and dynamic islands. So if we break that down a bit, what we're doing is we're selectively and progressively enhancing bits of server-side rendered HTML with some client-side JavaScript. And with that, we have some small, really focused chunks of interactivity within pages that were server-side rendered. And it's kind of a shift. We go from this model where we had a single app in control of the full rendering out of the page to this model where we have multiple entry points. Also, the script for the islands is usually delivered and hydrated independently. And basically, this allows the rest of the page to be just a static HTML. And that's exactly what the output of an island is, progressively enhanced HTML. But with the island model, as opposed to other approaches to hydration, you have more specificity around how this enhancement occurs. So it's better if we can visualize that. So that's a classic example of a blog. We have our layout, we have the title of our post, the content, and some interactions, sessions where we can have interactions like comments and some social sharing buttons. If we model that with islands, the layout of the page, the title, and the content, because they're static, and in this case they don't need any interaction, they can be fully server-side rendered. And then the page, the parts where we have interactions that are the comments and the social buttons, those would be those placeholders that are server-side rendered. And then inside them, we would have this app for each of them that is basically something that's server-side rendered and ships with hydration script, each of them. And you have a bunch of implementations for islands out there these days. You have standalone implementations like Astro, Quake, Marco, and others. And for a lot of frameworks like Preact, Solid, Svelte, we also have approaches to islands. And Marco is quite interesting. Who here knows Marco, by the way? A few, right? Yeah, a few of you. So Marco has been around since 2014. And Marco was brilliant because it shipped a very interesting combination of things. You had streaming rendering with automatic partial hydration and a very smart compiler that would generate optimized code depending on where that code would run, on the server or on the client. And with the automatic partial hydration you had in Marco, it basically allowed those interactive bits of your app to hydrate themselves. And of course, this hydration code is only shipped to those interactive components. Recently, in 2021, we got Astro, and Astro was amazing. How many of you know Astro? Wow, almost everyone. So yeah, Astro was built around the idea of, by default, shipping 0 JavaScript and having every island loaded in parallel. On top of that, Astro did 2 things that I consider brilliant. First, it was multi-framework. So you can build islands with React, Preact, Svelte, and others. But also, it allowed you to specify the loading strategy for each of your islands individually. So in this code snippet that probably most of you know, I'm using a React component with Astro, and I can specify, for example, if I want each of these to be hydrated upon loading, which is kind of immediately, or just when the browser is idle, or maybe when it becomes visible to the user for below the fold stuff. So you can come with really, really clever stuff. So yeah, islands have a lot of great things. You start by reducing the amount of JavaScript that you ship to your client, and that gets you to have faster metrics, like for example, the TTI. Because of that, you also have key parts of your content delivered faster to your users, which is great. And because you're doing SSR, you get traditional SSR benefits like better SEO. Islands might not be a great fit depending on the amount of interaction you have within your app. So if basically every bit of your page is interactivity, you might end up with a bunch of islands and you might be missing the whole point. But islands were not the only thing to try to change how we did hydration. In 2021, we also started to hear a lot about resumability. And the way I like to start thinking about resumability is by thinking that if we go back in time, we'll notice that a lot of the solutions we have for SSR these days, they're based on libraries that were not initially built with the idea of SSR. So a classic example was this. This was probably the one that got most famous. It was an experiment by Airbnb back in 2013 where they were server-side rendering Backbone. But actually in 2011, 12, 13, there was a bunch of experiments. People were trying to server-side render Angular, Backbone, React, which were initially client-side frameworks. So what if it was the opposite? What if things were built with SSR in mind from scratch? Again, people thought about that. This is this project called Opal Language. It was built in 2011. And this went way beyond just partial hydration. So basically, you would write code, and the compiler would slice client and server parts for you, client and server concerns. That was brilliant. Years later, we got Meteor, which I'm pretty sure some of you are familiar with. And Meteor had some of that, and it actually got some traction back at the time. And then in 2021, we got Quick by Mishko and Builder.io. And Quick had this thing of resumability, which is about pausing the execution on the server and resuming on the client without having to redo, like replay and download all of the application logic, everything that happened on the server. So as the name suggests, yeah, do some work, pause, and resume on the client. And you are reusing what happened during the execution on the server to avoid this extra work when the application boots up in the browser. And it does a lot of attaching global event handlers at startup time and then only running them when it's necessary. So if we compare that to the traditional hydration we were talking about a couple of minutes ago, traditional hydration usually is eager because the event handler creation happens before the event is triggered itself. And also, all of the possible events are created and registered. So basically, it's a next speculative approach. Also, you have client redoing what happened in the server. And last but not least, your framework, it has to download and execute everything to figure out the component hierarchy. With resumability, though, you have the opposite. You have a lazy approach, and only the triggered events are basically created as they are needed. And because you are leveraging a lot of data serialization, you don't redo work in the client. So if we visualize that, this is the classic example. You display some HTML, and then you deserialize a bunch of information, and that includes, for example, breaking apart the code for hydration for all of these event listeners, figuring out the application and framework state, and also figuring out the component hierarchy so that you don't do recalculations for components. And then, boom, magic, your application is interactive. You're probably wondering how that compares with islands or other approaches to hydration beyond the traditional hydration. So we can cut this to this if we compare it to islands, because with islands, usually we still have client redoing work that happened on server, and also things at islands, they happen at island level, whereas with resumability, not only the client's not redoing work, but it happens at a way more granular level that is subcomponent. If you're more interested, there is this amazing live stream by Ryan where him and Mishko go through the whole ideation of resumability. What's great about resumability is because you're not redoing work, of course, you get great startup performance. The rendering performance also tends to be better because only what's changed gets re-rendered. And you have things like fine-grained lace loading and progressive interactivity. What I don't consider quite great is, first, it is an official recommendation that you preload your critical page interactions so that users wouldn't have to wait them. So if you have a lot of critical page interactions, you might have to end up preloading a bunch of things. Also, the only option for people to leverage resumability per the definition we saw, is to use quick. And because of that, all of the discussions, resources, and everything are still quite tied to the quick community and to Builder.io itself. But I do think that quick is just a perfect example of some outside-of-the-box thinking that we need in the front-end community sometimes. Well. Now we're going to go at the same time backwards and fast forward to the years of 2017 and 2022. So if you think about when React 16 came out, people were talking a lot about hooks, about suspense, the new context API, and etc. But there's this one thing that was streaming server-side rendering. And actually, for me, it was one of the most underlooked things that we had back then. And streaming SSR was great when it came in React 16, but it was only after the React 18 umbrella of streaming SSR with selective hydration and the other amazing concurrent React things that it became more popular. So it's great if we think about how it happened before. So before, hydration in React could only begin after the entire data was fetched and rendered in the server. So because of that, your users, they couldn't interact with the page until it was complete for the whole page. And the bottom line was, the parts of the app that they were the fast ones, they had to wait for the slow ones for things to happen. Again, it's better if we visualize this on a timeline. So all of these are sequential and blocking steps. So we fetch the data and we render the HTML on the server, and that's when we get the first byte. Then we load things on the client and we get our FCP. And then finally, after hydration is complete, is when we get our time to interactive. With this combination of streaming SSR and selective hydration, this moves into this. And how was that? basically we're leveraging pipe to node string with create hood and suspense itself. And by doing so, React is now going to prioritize hydrating the parts of the app that the user interacted with before the rest. And also, because you have concurrent React, these components, they can become interactive faster by allowing the browser to do other work at the same time as hydration because of concurrency. The bottom line here is that now React doesn't have to wait for these huge components to load so that it can continue streaming HTML for the rest of the page. And you can be sure that when the HTML becomes available on the server, it's going to be added to that string and inserted via script tag in the right place. A lot of companies, they have really interesting use cases, and Vercel is one of them. They managed to improve a lot of performance of the Next.js websites by leveraging streaming SSR with selective hydration. Let's talk about RSC. Ooh. Yeah, time to hydrate. Pun intended. So it's crazy because we're discussing a lot of RSC these days, but back in 2019 or 18, we could see some PRs or some work in progress under this React Flight umbrella. So we had React Flare, React a lot of stuff, and React Flight was one of these React Fs. But it was only in late 2020 that we got this post announcing introducing zero bundle size React server components. And ever since this and the recent announcement of the app router in Next, we got like a huge cloud of Twitter discussions, and I don't know about you, but I kind of feel like the whole community was like trying to see how they all piece together server components, suspense, transitions, other concurrent React stuff, what was Next, what was React. One of the ways that I like to see server components is if you could do ahead of time server rendering of React, and this can be during build or even during the server. But not only that, server components are about having a routing paradigm that is integrated with data fetching and also with bundling. And as odd as it might seem, it's not 100% related to SSR or hydration itself. Now that we discussed islands and Astro, you can really think of how islands work because it's really identical. But the thing is, with Astro, we had this boundary. But here, with server components, the Astro-alike part is also React. So we need to draw on the boundary. That's why we have use client in Next Step Router. You're basically drawing the boundary between two module graphs. And each component can actually decide whether it's a server component or sticking with being like a client plus server component. There are three great things about them. The first thing is that the code for the server components is never delivered to the client. That's probably the most sold one. And that's great because in many implementations of SSR that we have these days, a lot of code is still shipped as bundles. The second thing is you get access to the backend from anywhere within the tree. And how many people use Next here? So you're probably used to having things like get server-side props or other things that your page or your parts of app router give you. But the thing is here, that happens at the page level. With that, we can have this access at any level of your tree. And the last point is my favorite one. These server components, they can be refetched while maintaining client-side state inside the tree. This is amazing because think like a search bar that you can fetch and refetch stuff but you're maintaining like the focus, the selection state, and that kind of stuff. What's not great is I'm particularly concerned about having a lot of data sent along the wire on every re-render. I'm not saying this is necessarily a problem, but I also feel a bit unsure about how much orchestration is needed, especially in terms of developer experience. And not to mention that a lot of that is still experimental. And just like with Resumability and Quick, you only have very, very few options to leverage server components, being the main one next with app router. There is one thing about server components is, just like Quick, it reminds me a lot of this tweet by Mishko, the creator of Angular and Quick, where he says that code abstraction and collocating client and server code is going to be one of our next big challenges. And this reminds me a lot of this thing called Jaxter. So Jaxter was a project initiated back in 2008, more than a decade ago. And Jaxter allowed you to do this kind of thing, where you had single file apps with logic that ran both on the browser and the server. You even had this attribute run at, and you could do server or both. And if I put side by side the state-of-the-art demonstrations of server components and what was in Jaxter documentation more than a decade ago, I kind of see similarities. Anyways, I think that me and a lot of us still need to learn about React Server Components. Tejas has this really good session where he goes through the creation of server components, like implementing your own server components. There are a lot of resources out there, really great live streams and videos explaining. And also, there's parallel implementations of server components like Waku. Waku was made by Daishi, one of the core maintainers of Zustand and other state management libraries. And he's basically implementing RSC on his own and documenting everything. That is great. There's also Bling by TenStack, which doesn't necessarily implement server component, but basically plays a lot of this thing of extracting and collocating client and server code. We talked about a couple of things: hydration, streaming SSR, resumability, islands, and etc. There's still a lot of other things I would love to discuss with, but we have 35 minutes. So let's talk about the future for a while. So I think that we'll be discussing a lot of routing and navigation, and we'll be coming back more and more to this discussion whether we want to have MPAs or SPAs and what are the drawbacks of each of them. By the way, there's this live stream by Ryan. I know I'm probably quoting Ryan a lot, but there's this live stream by Ryan that is like 4 hours ideating on both of them. I definitely recommend you to watch. We'll be also talking a lot and more about hydration. What are the problems? What are different approaches like parallel hydration, selective hydration, progressive hydration, islands, resumability, etc. We'll be discussing a lot whether we want to have 0 kilobyte JavaScript pages or not. And we'll talk a lot about code abstraction as people have been talking in the past. And more than ever, I think that we'll have a lot of posts documenting why something is going to be the next thing, the future. Just like what we're doing right now. So, a few closing thoughts. As you probably notice, the solution to a problem most of the time is only going to change the problem that you have. And while all of these technologies and approaches, etc., we discussed, it might seem that they are competing against each other. Actually, they are complementary. They don't completely solve the same issue. Instead, they focus on different parts of the problem. So with islands, we are reducing the JavaScript footprint by explicitly marking what goes to the client. And islands are really great at solving code and serialization and data serialization size and etc. Server components, you have the idea of islands, but now you have client-side routing and you have really great state preservation. And it's kind of the only island-alike solution that properly counts for state while doing this client navigation. And then we got resumability that has a whole different approach. Instead of reducing the amount of what is hydrated, you're trying to remove the execution cost of hydration itself. Also, the same pattern can be good and bad depending on your problem. And that's why you're going to see a lot of huge apps, enterprise scale stuff, using different patterns and different routes or different parts of the whole app. That's why I like approaches like this one. This is another post by Jason Miller called Application Holotypes. It was published back in 2019. And with application holotypes, he basically described a couple of common apps you might want to build, like social networks or gaming platforms or a blog app or an e-commerce, etc. And then he discusses, okay, how do you want to handle each technical aspect based on what you're trying to build? There's this more detailed approach to holotypes by Ryan, where not only going through the holotypes, but basically how you want to handle routing for a portfolio or for a storefront or for a social network. How do you want to handle hydration? How do you want to handle the rendering process? And so on. So I really like this way of seeing things. I know it might sound a lot like we're just going back to rendering HTML on the server like we were doing in the good old days. But I think that these days the boundaries are really different. With PHP and Rails that we had like decades ago, the boundary pretty much stopped in the server. It rendered pages, it accepted form submissions. That was it. Marco, in 2014, tried to basically push this boundary more. But I think most of us were kind of busy building SPAs. And then recently, we have things like Phoenix Live View, Laravel Livewire, or Hail's Hotwire, trying to push this boundary again, but they're coming primarily from backend and server technologies. And now we have quick and server components, and I think they're kind of like the latest attempt to view server and browser as part of the same system while fully respecting their concerns, their constraints. As you probably notice, software development continually goes through cycles, and it's really important to think what's different now and what were the brilliant ideas we had back then that just turned into lost art. Most of the things we're doing, we're not the first ones to try that. So what's different? And I have two good examples of that. This is a tweet by Andrew Clark back in 2018 where he basically shows that a lot of the fiber algorithm that we have in React actually comes from the double buffering, which is a strategy that exists in the game development industry for decades now. In 2021, Dan was basically linking to this post that's called Async Fragments, Rediscovering Progress HTML Rendering with Marco. And this post is from 2014. And he said that in 2020, 2018, etc., people were starting to explore a lot of things that Marco was exploring back then. And it's funny because that post links to another post from 2005 called The Lost Art of Progressive HTML Rendering. I know all of that sounds really, really complex, and I think it should be, because we're addressing what's uncertain about the web in a scenario where we have a diversity of connection qualities and device capabilities. And if we remember about 2010 with this whole thing of responsive design and etc., it was also tricky. We were trying to address like unpredictable amount of screen sizes, resolutions, and etc. I did the same joke last year, and I'm going to do it again, sorry. You know what they say, that the picture is worth 1,000 words? And this is me, almost a decade ago, talking about Ionic and Angular to native iOS developers and telling them, you should drop this native iOS thing. Angular is the future. That was, thank you. So yeah, don't trust speculation, don't always trust speculations and future predictions, because there's no silver bullet. You should identify your core metrics and always correlate these with business metrics like conversion rates, bounce rates, and etc., because these are the performance metrics that actually matter for you. I am MATHEUS ALBURQUERQUE. You can find me everywhere as Y Combinator. I'm a senior software engineer at Medallia, a mentor at Tech Labs Belém, and a GDE in performance. This slide and other speaker decks I have are available here. Muchas gracias for having me here.